Welcome back. In the last chapter we covered some of the most important structural basics relating to almost any programming language, not just C++. In this chapter 6, we are going to relax a bit. We are going to have some fun. Let's get better with our programming skills by playing around with a few programs that implement some of the portions we learned in the last chapter. So let's start. In chapter 3 we had learned how to write our first C++ program. In this chapter we will begin with program 2, 3, 4, 5, and 6. Program 2 requires that we accept a person's name and greet that person by the name. So to write the program, we first need to start the C++ IDE. I had mentioned in chapter 3, 2 ways to start the IDE. Method 1 is to click shortcut icon from where you have placed it. I have placed the shortcut icon on desktop. And so I double-click it from the desktop. Method 2 is to start the IDE by clicking the application file from installed location. I have installed dev C++ at f:/dev-cpp, and so I go to F drive, open dev cpp folder, and double-click dev cpp.exe file to launch C++. We are now on board the C++ editor dashboard. Let's next open a new source file to write down the C++ code. Click File, New, then Source File. Or use the shortcut key, Ctrl-N, to open a new source file. Write down your second C++ program on the notepad here. Save it in a folder of your choice. Then execute it. Execution means compile and run. Shortcut key F11 does both. Refer to chapter 3 if you have doubts. This is our program code. We will be using the computer's memory storage units to note down something. And then we will have output screen where the program would display something. So, what did we write in the program? The first line is the comment line. It says, "This is my second program in C++. Remember that comment lines don't get executed by the compiler." Second line is the declaration of header file. The IOStream library. The third declares namespace std, as it contains objects that executes output operations which help us display message onto the computer screen, and the input operations that help us receive values entered from the keyboard. Line number 5 declares the main function, within which we will be writing the functional code. On line number 7, we declare a character variable named n that can hold 20 characters. This statement allocates a memory space named n of character data type, occupying a memory size of 20 bytes. On line 8 we give the output command cout. It displays a message on the output screen for the user, "What is your name?" I type the name Ajit. Line number 9 is the input stream command cin. It means, what is received from the keyboard has to be streamed or directed to the memory variable named n and held in there. So, the copy of user entered value Ajit gets placed in the memory location n. Line 10 is the output stream cout. Note that here, we have 3 message blocks streaming into the cout object. Hi is the first message block. It's in double quotes. And so, it will be printed as it is. N is the second block. It's not in quotes. Hence the value of n will be printed. And finally, comma, welcome to C++ is the third block. It's also in quotes. And for this reason it will be printed as it is. What does it do? They collectively stream the message onto output screen and displays it. So here, first hi is printed onto screen. Then, n is replaced by its value from the variable stored in memory and then displayed. Here the value of n is Ajit. So Ajit is printed. And finally, comma, welcome to C++ is printed. All in a continuous sequential stream. This is how the output looks now. You ask the user's name, and welcome the person to C++ by their name. Did you notice something? The system does not accept a full name. If you type in the name as withAjitsaigal, it filters the name as soon as it encounters a space. C/N only accepts Ajit. And not withAjitsaigal. Let's rectify that in our next program. In program 3, we accept the full name of a person, and wish that person by the full name. I open a new file from the menu, or press shortcut keys Ctrl-N. I type in the program code as in here. Save it, and compile run it. I have saved the file as 3.cpp. Once again, let's go to our program tracking visualizer. Code is almost the same except for a few changes. Note that on line 3, I have declared a new library named string. I will be using some utilities from the string library. So I type the statement, #include string. Then on line 8, I have declared the memory variable n as a string. Remember that in the last program, we had used character variable n. Character variables consider a space as the end of line. And hence, the last program was not accepting full name of the user. This time, we are using the string data type variable, and it accepts space. Next, the system prompts for username. I type in the full name withAjitsaigal. On line 10, we have the getLine function. It's the getLine function that handles the C in object, and the string variable n. The copy of full name that I typed in gets assigned to the variable named n. Line number 11 is the cout stream that prints the message blocks onto computer screen. Here, the variable n get replaced with the full name withAjitsaigal. The output looks like this now. Let's next move over to program 4, where the requirement is to find area of a circle. Get the radius from keyboard, and find the area of a circle. Formula is a equals pi r squared. Use preprocessor directive to define value of pi as 3.1415. I type the code as in this file and save it as 4.cpp. Let's track the script on our program tracking visualizer. There is the comment, the header file, and the namespace declaration. Just to note, the comment is not mandatory. On line 4 we have declared the preprocessor, where pi is defined with the value 3.1415. What it does is, a memory location named pi is assigned to store the value 3.1415. Just to note, you can also define a character within single quotes, and a string within double quotes. Then at line 7, we declare an integer variable named r. This reserves a memory location with name r, to store integer value for radius. We next declare float variable, capital A. A memory location named capital A is reserved to hold a decimal value for the calculated area of circle. Then on line 9, we prompt the user to enter a value for radius. The message is displayed on the output screen. I respond by entering the number 5. The next line of code on line 10, cin, r, takes a copy of the input number, here 5, and assigns it to the memory location named r. On line 11, we compute the area of circle with given formula, a equals pi r squared. Let's look at the memory location named capital A, of type float. A will be assigned with the value of pi multiplied by r, and again multiplied by r. So the final computed value that is stored in variable, capital A, is 78.5375. Next, the line 12 is executed. It prints on screen the message blocks passed into cout stream. The r, in cout stream, is replaced as 5, from the memory location named r. Similarly, a is replaced by the value within memory location named capital A. The final result appears on the output screen as seen here. Area of circle with radius 5 is 78.5375. Okay, so let's move over to the next program. Program 5. Accept two numbers and find their sum, difference, product, and quotient. I write code for this program as in here, and save it as 5.cpp. Let's once again track the script on our program tracking visualizer. On line 6, we declare two integer variables, a and b. So, in the memory storage, locations named a and b are reserved to store integer values. Lines 7 and 8. User is prompted to enter first number. I type number 10. It gets stored in memory space, a. Lines 9 and 10. User is prompted to enter second number. I type number 5. It gets stored in memory space, B. Lines 11, 12, 13, and 14 display the sum, difference, product, and quotient of the two numbers stored in A and B. Here, sum is 15. Difference is 5. Product is 50. And quotient is 2. All is fine as of now. Let's next just reverse the values. Once again run the program. This time, assign 5 to first number, and 10 to the second number. What do we see as the result? Sum is 15. Difference is -5. Product is 50. And quotient is 0. Not bad. But wait. When you divide 5 by 10, the quotient is 0.5. Why does it print 0? Let's look where it was instructed to be printed. It's from here. A divided by B. Now, A and B are declared as integers. And it's obvious that the result has to be an integer. So, 0.5 being a decimal, is separated from the result 0.5 and we get result 0. However, we learned in last chapter about typecasting. Let's apply it here. I typecast A divided by B as float of A divided by B. Let's have a relook at line number 14. Compile and execute the program. On output screen, let's repeat entering the first number as 5 and the second number as 10. Here is the result. Great. We now have the exact answer. We will now look into Program 6. Requirement is to declare integer variables A and B with values 10 and 4 respectively. Then assign B to A. Next, add 10 to A, multiply B by 2, and print values of A and B. Finally, declare constant C with the value 5. Print C, check if you can change the value of C to 15. So here is the program for the task assigned. I have saved it as 6.cpp. On line 6, we declare integer variable A with value 10, and integer variable B with value 4. Memory storage locations are reserved for A and B. Value 10 is stored in A, and 4 is stored in B. Value of B is assigned to A. Value of A is updated by adding 10 to it. Value of B is updated by multiplying it with 2. We then display the values of A and B. Next, we declare a constant integer variable named C. Assign it value 5. And print it. No issues. It's perfectly working. Next I add lines 14 and 15. On line 14, I reassign the constant variable C with a new value 15, and on next line I try to print it. On compilation, an error occurs on line 14. It says that the constant integer variable C is a read-only variable. Yes, variable C cannot be changed because it's declared as a constant. Note that, earlier in this program, we had repeatedly changed the values of integer variables A and B with no issues whatsoever. I hope you enjoyed the programs. With this we come to an end of this session. We will meet in the next chapter on operators in C++. Until then, take care and have a nice time.